Okay, let's take a look at explore number two, the nutrient cycles. Go ahead and take this. What are the processes and features of the carbon cycle? Go ahead and take that as our essential question in your notes. Draw your template. Go ahead and make sure you put your date. And this is from Discovery Education. Um, that should have said Living Earth. So let's go ahead and add that there. Living Earth 2.4.2. Okay. And hit pause and tell me what you know or what you think about that. What are the processes and features of the carbon cycle? All right. Well, hopefully you took a moment to just dig in your brain. I don't want you to be referring to your notes or looking at the text for that question. We just want you to think about what you know. So carbon, like the water cycle, which we've talked about previously, water cycles through our environment, Earth. We see it in the different spheres. Well, carbon's the same way. It can exist in the various spheres. Um, it can be stored in some of these spheres for long periods of time. It can uh, move in between the spheres on a cyclical basis. And that's what this is referring to. Carbon is a fundamental, not just it is the fundamental element in organic compounds that is usually referring to living things. It's very important. So, in a nutshell, how does this stuff move around? Well, you have autotrophs. They are things like plants and archaea, bacteria. They're able to produce their own food, right? Their own energy sources using carbon dioxide from the air. And as you guys are aware, they're going to transform that carbon dioxide into um, chemical bonds. The energy is going to be stored into chemical bonds, such as sugars. Now, you and I are heterotrophs, so we can't make our own food that way. We either are going to directly eat the plants and get that sugar, or we're going to get it indirectly by eating animals that eat the plants, right? Um, this usually brings us to the process of cellular respiration. Remember, there is those three stages of cellular respiration. The first one starts with breaking down sugar, right? Glycolysis. And in the presence of oxidation, you're able to progress to the Krebs cycle and then to the electron transport chain. Um, in all of this, you're trying to break down that sugar molecule to release energy, right? And then you breathe out that carbon in the form of carbon dioxide, CO2, which is released during the Krebs cycle. So, letter B, you can see that carbon cycles through the environment from reservoirs. Remember, reservoirs are things that store things. Rocks can be carbon reservoirs. The ocean and sediment can be reservoirs, large storage containers for carbon. Um, this carbon is able to then cycle as well through and to the atmosphere, mostly as CO2, uh, and then back into food webs, right, through photosynthetic organisms. And it just kind of continues to cycle through like that. Now, organisms such as you and I, all animals, we store carbon in our bodies. When we die, the carbon is going to be released through a process of decomposition. Some of it will return back to the atmosphere, especially if you have other animals that are eat in our bodies, and right, they do cellular respiration and release some of that CO2 back into the atmosphere. Um, Sometimes our body is just going to get buried in the dirt, and so a lot of that carbon is going to get buried into the dirt as well. Sometimes it can get buried quickly in what we call anoxic conditions, where there's not a lot of oxygen. Think about being buried quickly in mud. Then that carbon might get locked up for a long time as it turns into sedimentary rock, perhaps over long periods of time. Right. Remember that CO2 that's locked up in things like the ocean floor sediment, right? That's going to usually be locked up in things like calcium carbonate type of rock formations. And when we make concrete, we release a lot of that carbon back into the atmosphere. So again, that's just kind of showing you that this process is constantly cycling. Volcanoes, their eruptions produce a variety of gases, and some of those gases are carbon dioxide, right? So again, just taking a look at all these different forms here. Burning fossil fuels, when you burn wood in a fireplace or a campfire, you're releasing a lot of carbon that's been locked up in the cellulose of the plants. If you're burning oil, gasoline, you're burning hydrocarbons and releasing those carbons back into the atmosphere. And again, we're just talking about all the different ways that carbon is cycling, right? It said that in your text that previous to the Industrial Revolution, carbon dioxide had pretty regular, consistent levels in the atmosphere. And it's only since the Industrial Revolution that we've seen about a 35% increase in carbon in the atmosphere. So, human caused, right? Anthropogenic is the term for that, human caused. Recent increases in global temperature is closely correlated to increases in atmospheric CO2. This is probably important. Take a look at step number 5. CO2 is referred to as a greenhouse gas because it can retain radiant heat. And so there's part of that connection to number 4. Why do we see an increase in global temperature? Why does it correlate with an increase in CO2? Because the CO2 is good at trapping radiant heat that enters into our atmosphere from the sun, warms up the planet, and produces, and the planet then radiates that heat in a kind of a different form. And CO2 is very good at trapping that stuff. Okay. And interesting here, a little side note there, about 50% of CO2 that we produce these days remains in the atmosphere. All right. Well, I think what I would suggest for you is make sure you click on your resources. For example, when you click on the carbon cycle, you're going to have this nice animation. You're also going to have a nice video that talks about the carbon cycle as well. And also some good images, right? Just kind of showing you a flow chart of the carbon cycle, different elements of it, different aspects of it. So make sure you take a look at your resources just to round out your understanding of this. And take a moment, write a summary paragraph, if you will, and we'll talk to you soon.